My dear students, now we are going to look at design of full adder using decoder. So now we will take up the full adder. What is full adder? We know already. So for a full adder, which is a function of say A, B, C, for which the output sum, which is a function of ABC, will be sigma m. Sum is 1 for 1, 2, 4, 7. Carry out, which is also function of a comma b comma c in, which is sigma m, right? It is for 3, 5, 6 and 7, which we know. What is the meaning of this is it is 1 for 1, 2, 4, 7. This is with respect to what we know as sum of products. If you want to represent the same, it is in SOP form. If you want in POS form, what is product of sums? The same sum, which is function of a comma b comma c n, but now I can write as pi m, for which it is 0. So out of 0 to 7, if I leave 1 to 4, 7, rest will be your pi m, that is it is 0 for 0 and 0 for 3, 0 for 5, 0 for 6. If I combine for which it is 0, for which it is 1, I should get all 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7, right? So I got totally 8. Similarly, what I am trying to say is for CO, in a similar way, I can write AB comma CN, which is equivalent to pi m, for which it is 0 is, for which it is 0, it is 0 for 0, 1, 2, comma 4, 0, 1, 2, 3, 4, 5, 6, 7. So in this way, if you see this, it's like this. This will give you 0 to 7 total. And if also you see this, it will give you for all minterms 0 to 7, because we are expressing the sum and carry for which minterms it is 0, for minterms it is carry, for which minterms it is, here it is max terms, here it is minterm, for which minterms it is 1, for which max terms it is 0. So once we know this, you can implement using decoder. So if at all you want to implement this using decoder, how many decoders required to implement full adder? We need only one decoder. What I can do is, I'll take one case of a decoder for which I have three inputs. One is A, B, C in. I'll take enable active low connected to ground will be on. So I'll be having the outputs 1, 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, then 7. 3 to 8 decoder. Okay, this is your decoder. Then what I am trying to do, I am trying to implement sum. For sum, what is required? 1, 2, 4, 7. So you take 1, 2, 4, okay, then you take 7. For this, what I try to do is, I will take a OR gate, I will connect it to OR gate. So what I will get? Sum. But I want carry out. If you want carry out, what I need to do? I take 3, I take 5, you take 3, okay, you take 5, you take 3, sorry, you take 3. When we take 3, 3, 5, then what I need? 6 and 7. So you take 6, this is 7. You once again OR them. Then you will get your carry out. So this is how, by using a 3 to 8 decoder, By using SOP expressions, I can implement a full adder. If I use POS expressions, I can also implement. I can also implement this decoder. Instead of this decoder, I can go for active low output decoder. So now if I go for active low output decoder, let me implement here itself. Okay. So what I try to do is, I try to take up the decoder now with what exactly known as active low outputs. Active low output, 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 active low output. 3 active high inputs, 1 active low enable which is connected to ground. A, B, C are inputs. Now what exactly that we are trying to do is, when it's active low, what I can do is I'll connect 0, 1, 2, 3, 4, 5, 6, 7 as per my requirements. What is my requirement? 1, 2, 4, 7. 1, 2, 4, then 7. You take this, connect it to the OR gate. Okay. We will connect it to OR gate or AND gate. We will connect it to an AND gate. Okay. Once we connect it to the AND gate, what exactly from this we are getting max terms actually. So I don't want max terms, I want min terms. So put a bubble here. I have to use a NAND gate. This will give you some. Similarly, you take 3, you take 6, you take 7. For this use one more NAND gate, then you will get your carry out. Okay. Similarly, you can take, this is one possible solution. This is also a possible solution. Okay. What is the difference between this one and this solution? Here it is 3 to 8 decoder with active low outputs. Okay. So similarly, with respect to POS functions, you can take active high output decoder, active low output decoder, and one can solve. So let us complete that quickly. What is that is, I'll take a decoder of active high outputs, Now I am using POS function, not SOP, POS. So this is 3 to 8 decoder, 3 inputs, nice. Then there is a enable which is connected to ground. 0, 1, 2, 3, 4, 5, 6, 7. You take 1, 2, then what exactly? The expression that we have looked for. So if it is a POS, it is 0, 3, 5, 6. So 0, 3, 5, 6 I need to take 0, 0, you take 3, then 5 and 6. You take 5, you take 6. What I need to do? This I am supposed to OR them. Okay, OR them. Then what you are doing is min terms, but what I want is max terms. So put a bubble, then this is your sum. If you want your carry, for carry expression is 0, 1, 2, 4. So you take 0, 1, 2. So you can take 0, you can take 1, you can take 2, right? 0, 1, 2 is available, and we do require 4. So you can take 4 from here. Okay. So you'll take there. What I try to do is, for these 4, okay, what I try to do is, I use once again a OR gate followed by bubble is NOR gate, which will give you carry out. Okay. So this is how, this is A, this is B, this is C. Okay. So similarly, how I am doing is very clear. we want max terms, but what we are having is min terms. Output is min terms. To get max terms, we are putting a bubble. Here inputs are active high, we are getting max terms, but we want min terms. So max terms ANDed followed by bubble will give you min terms, because we want to get these expressions using active low outputs of decoder. Whereas this, there is no bubble here, so we are using a bubble here to get max terms. Similarly, for active low outputs, I can solve the last possibility. What is that that we are trying to look is this. What is that is, let's start with a decoder, right? We have three inputs A, B, C. There is an enable input which is active low connected to ground, right? Then we are having the outputs 0, 1, 2, 3, 4, 5, 6, 7, but these are with bubbles. So what is this active low? But what I want to implement? I want to implement POS, product of sums. So what are the expressions that we have? 0, 3, 5, 6. So already they are there. What they are there? Simply by using AND get. 0, 3, 5, 6. You take 0, you take 3, you take 5, you take 6. Okay. Max terms are available. Just AND them. Then your job is done. Just AND them. Because of this bubble, they are become max terms. Okay. Just AND them. This will give you some. I want carry out. For carry out, what is required? I need, say, 0. I'll take 0. I'll take 1. I'll take 2. Okay. 0, 1 to 4. So I take 4 from here. Then I'll connect it to an AND gate. This is going to give me carry out. So this is how I can solve, or I can implement full adder using decoders.